Sadly, yesterday I wasn't able to save my recording as I messed up. I accidentally deleted too much. But today, hopefully, I will do a better job at both keeping what I should in terms of recordings and at explaining better how to do TDD in problem solving. So today's task, we have a day 2 already. I made a few changes, by the way, in my repository. So there are a few improvements. I added pipelines, and I added code.sc to measure my code quality. So now with pipelines, I can see that I indeed solved my tasks correctly, that all tests are passing, and code coverage if I wanted to. So yeah, it's all there. I can see passed and all my tests. Cool, right? So today we move on task 2. And I'll try to read the task and at the same time make the spec out of it. So I think I'll move this to day 1 and here. Now we are at day 2. Awesome. And I should have installed ReSharper, but I forgot. All right, so of course we start from a test class, and I need to skim through the text quickly to understand what we're testing. So I'll start reading. On the way to your gravity assist around the moon, your ship computer beeps angrily about a 1202 program alarm. On the radio, an elf is already explaining how to handle the situation. Don't worry, that's perfectly normal. The ship computer bursts into flames. You notify the elves that the computer's magic smoke seems to have escaped. That computer ran int code program, like the gravity assist program it was working on. Surely, there are enough spare parts up there to build a new int code computer. An int code computer is a list of integers separated by commas. Alright, so it seems that we're testing int code computer. So int code tests. And some input. I think my test for week 1 will fail now because I added one level deeper the file, so it's probably failing. File not found. Yeah, file not found. So I need to add the path update. Input. I also probably need a root path as a constant. So private static const. I don't need static, it's const. So private const root string, and the path is no longer input but day 1/input. And here I will put $. and root. Good. What's wrong? It must be a constant expression. That's no good. Okay. That's a failed attempt. If it has to be constant expression, I cannot do what I did. So let's replace them with this. So all the input in this file will be replaced with day input. Yes, please. And accept this one. Perfect. The same in this one. Place. And if I run the tests again, now they should pass. Lovely. Now let's continue on what we're supposed to do. So we said we're going to test int code tests. Int code computer. So this is our test file. We don't need anything about it. Let's continue. So an int code program is a list of integers separated by commas, like 1, 0, 0, 3, 99, 99. To run one, start by looking at the first integer called position 0. Here you'll find an opcode either 1, 2, or 99. So it seems that we'll have an input as a list of integers. So I don't know what I test yet. I just know that it will be a list of integer. What am I saying? Int. And separated by commas. Numbers, I guess. Or a program. It's a program, actually. So this is our input. Let's include the attribute xunit for xunit. Now I need a class data for providing myself with the input. Type of int code int code input, I'll call it for now. Int code input. So this is an attribute that says we take input and it's a test. And this is an attribute that says that we take input from a class that supplies us with input. Because otherwise we cannot do it from... We cannot use non-primitives in inline data. So I need to call it, and I think it has to be public. Actually, it doesn't have to be public. Internal. And it should be enumerator, so that we implement no enumerable definitely not this one. Get enumerator. I think so. Let me quickly reference xunit class data. Right, I enumerable, and then I need to say what type it is. That's object, and get enumerator. I don't think that this one is mandatory, but this one for sure. So good. Let's go back. So I need to return right. Yield a bunch of stuff. Yield return a list of input, basically. A collection, an array of input. That's basically what inline data is. So we have that, and it works just fine. So we create this. And in our case, I don't know what that is yet. In our case, that's actually, I'll make this more clear. The first parameter is the list of ints that takes whatever numbers we want it to take. So an int code program is a list of integers separated by commas, like 1, 0, 0, 3, 9, 9. Let's include the generic, and let's remove the non-generic. Good. Oh, I need to implement it explicitly, right? Oh, right. I need this bit here. Now I don't need this. And for this one, it's this. Good. So we just implemented our first encode input. So let's continue. An encode program is a list of integers separated by commas, like here. To run one, start by looking at the first integer called position 0. That one. Here you will find an opcode, either 1, 2, or 9 to 9. In our case, 1. Okay. First, actually in a test, I think it makes more sense to write that. First digit is opcode, either 1, 2, or 9 to 9. The opcode indicates what to do. For example, 9 to 9 means that the program is finished and should immediately halt. Okay, good. So that means that I can pretty much make an enum out of it with a value. So I'll call it opcode, and it's my enumerable enum, a public enum, and we have, so the opcode indicates what to do. 99 means that the program is finished and should immediately halt. Encountering an unknown opcode means something went wrong. Yeah, 0, I guess. No, I'll -1 is a good one. Finished. Opcode 1 adds together numbers. Adds together numbers, read from 2 positions, and stores the result in the 3rd position. Opcode 1 adds together numbers read from 2 positions and stores the result in the 3rd position. The 3 integers immediately after the opcode tell you these 3 positions. The first to indicate the positions from which you should read the input values. Okay, addition is is 1. So program halts. Opcode 1 adds together numbers read from 2 positions and stores the result in the 3rd position. And addition, sorry, this is the addition. Unknown, unrecognized opcode. The 3 integers immediately after the opcode tell you these positions. The first, to indicate the positions from which you should read the input values, adds together numbers read from next 2 positions and stores the result in the 3rd position. That's pretty clear. Yes, at which the output should be stored. Perfect. Once you're done, okay. So for example, if your int code computer encounters 1, 10, 20, it should read the value at positions 10 and 20 at those values and then overwrite the value at position 30 with their sum. Easy. Okay. Opcode 2 works exactly like opcode 1. Except it multiplies. Okay. So multiply. Finish, unknown, add, multiply. Multiply is multiply is 2. And I'll borrow this, multiplies together and overrides stores or overrides. The result in the third position. Good. Once you're done processing an opcode, move to the next one by stepping forward 4 positions. Adds together, multiplies together, and this terminates. Step ahead 4 positions. Why 4? 1, 2, 3, 4, 5. Thank you for following Carbon Chain. All right, now I added comments, and I should add a comment for this one as well. Steps ahead 4 positions. Good. So this is done. We got this. Once you're done processing an opcode, move to the next one by stepping forward 4 positions. Done. For example, suppose you have the following program. Now we can go back to our input and finish the input. So suppose you have the following program. For the purpose of illustration, here is the same program split into multiple lines. The first 4 integers are at the position 0, 1, 2, and 3. So 1 plus 9, so 1 means I add together these 2 and I store the result here. The positions of the 2 inputs 9 and 10, and the position of the output 3. To handle this opcode, you first need to get the value at the input positions. Position 9 contains 30. Oh. Position 9 contains 30. Okay, I got it wrong. Position 9 contains 30. I lost it. 30, and position 10 contains 40. Yeah? We add 2 together, we get 70. Okay. And then we move on by 4, because we need to step through what we did with this one. Okay. Makes sense. Let's go back to opcodes and add this clarification. Adds together numbers read from the next 2 positions. It doesn't read numbers from those next 2 positions, but from it reads the indices. So adds together numbers read from the next 2 positions, adds together numbers read from the next 2 positions, their indices. And stores the result in 3rd position. Their indices and stores the result. Int code literal roles. Right? We got that figure it out. Back to test. So this is our input. And another list for output, I guess. Add these numbers together to get 70. Then store this value at the output position. Here at the output position 3. Yes. Is at position 3, so it overwrites itself. Afterwards, the program looks like this. Yes. Step forward by 4 positions, and I'm here. To reach the next opcode 2. Yeah. This opcode works just like the previous, but it multiplies instead of adding. The inputs are at positions 3 and 11. So 99 and 50. Is it? 70. Huh? Why 70? Oh, you start from that start and not from... or not. Wait. Step forward 4 positions. We did. We end up at 2. So 2 says multiply. This opcode works just like the previous. 3. So 9 was 1. 9 was 1, 2, 3, 4, 5, 6, 7, 8, 9. It was 30. So you start from the beginning. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you start from 0 always. So if I take 3, is that my 0? 0, 1, 2, 3. 0, 1, 2, 3. So 70 I got where it's from, and 11. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah. Okay. You always start from 0. All right. I'll mark that down. Not relative positions, in other words. These positions contain 70 and 50 respectively. Got that? Multiplying these produces this much. Yes. This is stored at position 0. Why? Why at position 0? Because the... Why at position 0? Oh, the third one indicates the position that in a third indice position. In a third indice position. Index. In a third index position. Okay, makes sense. Okay, good. Stepping forward 4 more positions arrives you at opcode 99, halting the program. Here are the initial and final states of a few small programs. So this one becomes this, and I should place it in my input. All right. Doesn't really matter if I format it or not. For clarity's sake, I will not. I mean, I will for clarity's sake, because this better illustrates the flow. Right? Perfect. So yeah, that's the first input. Now I need the second one. Okay. Second becomes this. Okay, with this, I will stop for now. I have input for my test. Now I need code for it. I have bare minimum input. I think better if I make something very simple first. So I need the most simple input, possible input that I could come up with. So I comment this out for now, and I add the most simple possible input. Here we go. And the output. And I'll go back to my test, and I will write code for it when I don't have code for it. So, int code computer. It has, so we need to create a computer first. Maybe it's a compiler rather than a computer. Processor, int code processor. All right, so we have int code processor. We say int code processor calculate compile. Is it compile? Yeah, compile this input, this program. And there's our output. And the output should be, now let's include fluent validation, assertions. So compiled should be, let's create a class so that we can, do stuff with it. Let's generate a method. Let's move the class to where it belongs. Let's include the class from, oh, it's there. Let's change the namespace. And is it still working? Okay. It shouldn't. Okay, now it's public. So we created our processor, we compiled the program, and we say that the program should be equivalent to, should be I think equivalent asserts if object is equivalent to another object. Expectation. So we take two inputs. Program, more like code. This is our code, and this is our compiled. Raw code, compiled code. Int compiled code. So we take raw code and we get compiled code. So our compiled code should be expected. Our compiled code should be as expected code. So if we go now here, let's say that it returns an empty list of ints. So what did we just do? We created the most stupid but compiling test that we could have. A bracket is missing. If I run my test now, I mean, if I don't run my test, but I build it, it should build. It should build and it should discover my test. I don't need this anymore. So let's see what happens. I think I have my chat box too much over over the stuff. Not really, it's on the properties. Yeah, it's dead on properties, so that's fine. I'll move this a bit up and scroll down so it's harmless now for sure. Right, so what do we do? It says that something is locking the project, that we cannot copy a DLL. So it happens sometimes. And there is a stupid solution that I can do. The only solution I know that works for this kind of problem. So if you go to week 1 and bin, you'll see that there is a debug. Okay, there isn't. It's for test project. So if I go to test project, you'll see that there is a debug that after clean wasn't really cleaned. So the solution for this is to simply, you cannot delete it, you cannot overwrite it, but you can move it. So that's the most silly solution that I know, but it works. So if I go to, I'll create a TMP, I guess, TMP, and move it, the bin to this. It should be moved. It wasn't, but the key point here is that the file, okay, never mind. It sometimes works if I move bit by bit. So at least I know the files that are locking it. So awesome. And for some reason, if you move it like this, it suddenly works. And I have no idea why. So essentially, okay, bin is locked. That's great, but there's nothing in it that would mess our things. So we're good. I don't care about this. Now it should work. If I build again, whoops. If I build again, it should work. Build. So as you can see, build succeeded. And as you can see, our test has been discovered. If I run our test, it should fail. Obviously, because collection to be with 5 items but found an empty collection. That is true. Right now, our compiler returns an empty collection. And at this point, we start implementing the code. No longer hacking it, but now actually implementing it to do what it should. In a minimal way, but in a proper way. Some people say that you should write more like hack stupid code and be a lazy developer writing unit tests in a TDD manner. I don't really agree with that. I prefer not wasting my time writing test for a test. A nice flow is good, but writing a stupid test, like, which is obviously, I mean, writing stupid code just to fulfill the test just makes bad habits, I think. So, let's start writing some code. So we take a list of integers as our program, and we need to compile it into another program. So we start from a new list, a cloned list of the same one. So compiled is program.clone. Because ideally we don't want to take the original input and modify it, even though we can. So we can create a new list from the previous list or add a range and so on. So list of ints, and we take in a program. So we created a list with the initial elements of the previous one. Return compiled. So now the most trivial case. We traverse the list, but we don't traverse it by a for. We traverse it not by a for each, but with a for. So we start from 0, obviously. And we say that while index is less than total, so in other words, compiled dot count, we say that we increment the index. We don't do anything with it, actually. We will never increment the index by a normal counter, so we need to do a while loop here. So while we start with index at 0, and we say while index is less than compiled dot count, or index is not opcode dot opcodes. Oh, no. Really? I managed to get the same name of a class from some reflection library. I didn't mean it, guys, I swear. Opcode. Right. Opcode finish. End of program, probably. Finish is fine. So I'll make a function, I think. Private bool is end of program. So we take in, what do we take in? What do we take in? A count, an index, that's it. So we return this condition. Return this. I didn't want make a one-liner because I think it's a bit too long. I'll just give it a list, whatever. Program, I guess. Yeah, program. Program.com. Good. So is a program at the index of this program. So while that's the end of program. And it's iList. All right. So we say that while it's not end of program, we take the first, it's not index, by the way, it's program index. Good. Okay, so we say while it's not end of program, we work with it. So we say if let's make it stupid for now, we'll refactor later. If switch switch we say we switch so we take whatever index we are at the moment. Var code int code. Yeah, code is good. Var code is var literal. Yeah, literal is good. Literal is so we take our compiled program at this index and we check what it is at index at that index, and that's our opt code. What's wrong? Opcode, not optcode. So we have our opcode, and now we say that we switch the opcode, and if opcode is add, we do, that's not how you write that, we do something, private void add. We'll figure it out later. So we do addition. Else we do multiplication. And when you do the addition, you know the rules. So you you take the index. So you take the current index and you pass it to those. And at the very end of the while loop, you say next how do we call it, the step that we make after we're done processing. Opt next optcode step is 4. So we say index is next opcode step. For now, this looks ugly, but we will see what can we do with it. Okay. Private void opt code function int index func index. Actually, no, it's an action which takes an index operation. So I anticipate that, as in the assignment, it was said that addition and multiplication essentially are the same, just the things I multiply and add are different. So I might as well implement it in one step, and here just, refer it. That'll be much better. Okay, and default. I don't need the unknown one, now I know. So if I have an unknown optcode, I will terminate. How do I know if I have unknown optcode? That means I failed casting. What happens if I have unknown optcode? The optcode indicates what to do, and counter unknown means something went wrong. Okay. Something went wrong. Red. Undefined optcode. Why do I need a num, by the way? Why can't it be a constant? That will make my life so much easier, actually. Public static opcode, and this will be public const finish, an integer, public const add, so I won't need to cast it myself. public const. Recently, I actually started to dislike enums and use constants way more. I don't know. It's just cleaner in my opinion. No need to cast all the time. Public const int finish at multiply public static opcode class. I forgot. KD align save perfect. So I no longer need to convert anything. Perfect. And this saves so much trouble. Okay. So what do we need? We have a literal. We say if it's addition, you add. If it's multiplication, you multiply. And if default means throw unrecognized opcode exception. And we supply it with the one we got. Why doesn't it let me create an exception? Come on. Come on, man. So we create a new class. Unrecognized opcode exception. Public class, which is an exception, which is built. Pretty simple. So it takes in an integer, literal, and we say that unrecognized literal is this, and it was unrecognized for something went wrong. Yeah, just like in the assignment. So where's my processor? Where am I working at? It should be there, so I should move my code up there. Throw new exception. And this should go all the way there. Perfect. I don't need the constructor. What's wrong? Default and break. And this also break. Default doesn't break. Good. Because it's exception throw, so I don't need to break. Perfect. And my compile program iList. Yeah, I return iList as well. Good. So first we copy the list to a new one. Then we say if, then we iterate while it's not end of program. And then we say if so we take the literal and we say if literal is add, we do addition. If literal is multiply, we do multiplication. Else we say that it's unrecognized literal. Not really. Yes, really. Okay, good. And in the end, we say that we move by 4 towards the next index, as that's our opcode step. In the end, when we're done, we return a compiled program. Now the addition and multiplication, or in other words, opcode function. So, it's actually a function that we take here. And we take two integers and return a third one, the result. So when it's multiplication, we say that we take an index and our function is given two ints. I call it AB. We add. I probably should put it another line or something. I don't know. Index. Yeah, this is fine. And for this one, it's similar but multiplication. Multiply. And now let's implement what we do with them. Probably can close it here. Okay, implement. So I say that first number is I need also a list to take it from. So I need a list and an index, which is a program, and then an index, right? And then I say a pass, program, an index, and a function. Perfect. And I say that the first number is program of index plus 1. The second is program index plus 2. And I'm lying because that's not true. First index is program index plus 1. Second index is program index plus 2. And now first number is program of index of first index And second is program of second index. And if we don't do if, result is operation which takes the 2 and we store operation where third index is program index plus 3 and we store the result at that index. Yes. Okay. I'll probably put this here and the 2 here. Makes more sense, I think. Done. It's implemented, except that we need to pass a program now, the compiled one. Compiled. It takes a list. Can I convert from list, from generic iList to list? Why? Oh, right. iList, not list. Awesome. Add, multiply, throw unrecognized opcode exception. Perfect. Don't really like the switch case. I could use a dictionary. Dictionary to pick a function and feed it. Not worth it, I think. This is good enough. So let's go back to our test. Right, we need to add a using statement, the one that we had in day 1, except it's day 2 now. And we do what we do. So if I run this, it should succeed. To be 2, but found 1. Item 0 to be 2, but found 1. Okay. The input to be 2, but found 1. This one. Wait, what? Yeah, it should be 2. Good point. Did I make a logic mistake? So my function, first index is 1 ahead, second index is 1 ahead, third index is this one. So first, second result is not second but third, right? I see. Run. But found 1. Program. Here I pass program, compile it, return the compile thing, and I say that it should be as expected, but it's not. Three. So I go to index 0 plus 1 and I take this one. First index is 0 plus 1. First index. Second index is also 0. So I do the operation. Since it's add 1, I do addition. I do addition. I add two things together. Index. First, second. Wait a minute. Why is not second? Why is second not used? Why am I adding index? What the? Come on, man. Okay, it's getting late, guys. Really? Still? I take first and second, and I store it to the third. Index plus 3. 0, 1, 2, 3. Okay. Let's see what we got then. Okay, it didn't even hit that. Why didn't it hit that? Because my end of program is malfunctioning. While not is end of program. Genius. Perfect. Okay, let's continue with what task set us to do. Let's go to the test input and let's add all the scenarios that we have defined. So first one we already wrote. Second one we did at the start. Third one, let's take this. take this and one more. This becomes this. Awesome. Now let's build so that tests are discovered, and let's run the missing tests. It worked, really? Holy shit. Awesome. All tests pass. Surprisingly fast too. That's it. So what's left? The puzzle input. So that's the puzzle input. I also didn't cover the edge cases. I should probably, before I approach it. So this is valid input. I saw a few things I can improve on my program. Good night, Roloff. I wish you the best of luck. You're welcome. It's for everyone. I wonder why it's my chat. Oh, okay. I see your message there. It's not lost. But it's kind of refreshing pretty fast. So maybe I will remove it all together next time. I'm not sure why is it refreshing so fast. Anyways, let's continue. So this is valid input. Opcode input. Yeah, I think I will all the way till Christmas. I'll try my best. It's actually fun. And one for invalid. All right. So invalid would be one with no 9 to 9, one with 9 to 9 as second, empty list, empty list, empty list. Empty list will return empty list. Empty list is valid. So I could add it here. Why is it so derp in formatting? What the hell? Right? Empty list returns empty list, and invalid. This is invalid. This is invalid. What else is invalid? If it's 2, it should do the same. If it's 1, it should do the same. Doesn't matter actually. Also, if it's 9 to 9 immediately, it's also valid. Because it spawns the same thing. And invalid. Okay, good, good. This is invalid because not enough. Let's see at the example actually again. Nine to 9 has to be here, right? Okay. Stepping forward at halting the program. So it either reaches the end of line or halts. So in this case, I say, yeah, this is actually a valid one. I say, yeah, this is valid, but what the hell am I writing? This is valid. This breeds this, and this breeds zeros. So I should also put this as valid. Now invalid ones. If I take 0 at the start, it will be unrecognized. If I take did I have 9 to 9 anywhere? Yeah, I did. Okay. So 0 at the start will be invalid. One at the start with no second symbol will be invalid. And the same for 2, which is irrelevant. That's it. So unrecognized literal, and this is out of not enough indexes to add by the rules. So how do I handle those two? I guess I'll put them in a try-catch block. Index out of range exception. Throw. Can I add extra information? Yeah, I can. I can say which index it was. Or at which index it was. Yeah, I can say at which index it was.